Okay, this is a really unique section because we're not going to really be working out problems like we have in other sections and we will do in later sections. But instead, we're kind of getting a bunch of ideas here. Talking about designing experiments and collecting data, and we're getting a lot of ideas, a lot of vocabulary, um, and we're really going to be using that to think about um, things that would be fair, things that would not be fair, that would be biased. How do we set up experiments? What's a good way to ask questions? Things like that. So as we get started here, um, this is going to be a lot of me kind of reading my notes here and hopefully then explaining things as we go along. I tried to be very clear and explain it in my notes, but we'll see how it goes. Okay, most of the study of statistics is talking about how much things differ. And we call that the variability of data. Variability is really how things vary or how things differ, how far apart things are, how closely together that they are. These are all of the things that we use statistics to help us to discover, and especially experiments and things like that. Well, there's a lot of different kinds of variability. There are actually four different types that we talk about here. The first is measurement variability, and this has to do with actually measuring things. So you'll see that I said, you would hope that if we were to say measure, take a measuring stick or a measuring tape, and we were to actually measure the length of something, well, hopefully we would all get the exact same measurement. But we know in reality that's really not going to happen. Sometimes, some people are more precise. Some people, kind of ballpark things a little bit. So there are differences in the way people measure things. That's measurement variability. Then we have natural variability, which is how things differ in the natural world, just by nature. And so my example and the example that they used in the book was even identical twins, which we think of as being absolutely identical. Well, they're truly not. They're different. Their parents can tell them apart. They may have a different personality trait, or they may be one may be good at math and the other one good at um, baseball or something like that. So there's always little differences, little different quirks that people have, and that's just natural. So that's our natural variability. Then we have what's called induced variability, and induced meaning you are introducing something to create a difference in an item. So, like, if you were to do an experiment to see how plants reacted to a different type of plant food, you were to say, okay, this group of plants I'm going to give this kind of food to, and this group of plants I'm going to give another kind of food to. You are introducing some kind of a stimulus that it could be the difference between how these plants grow and react, and that's what you're experimenting on. So that's induced variability. Then we have, lastly, what's called sampling variability. And sampling variability is really important because it depends on how you get a sample of your items or your people or whatever it is that you're experimenting or surveying can make a huge difference as to how your data comes out. And we're going to be talking about samples and populations here, so you'll get a better idea of what that is. But it really depends on how you sample, because there could be a big difference there. That would be your variability, your sampling variability. Okay, so I should hope that you're asking the question now, well, exactly what is a sample? So I said, let's look at a simple example. Let's say that we wanted to know how the parents of our entire first grade class felt about some change like school start time. Well, that would be what we call the population of the study, the entire group that we're wanting to find something out about. But a lot of times it's really difficult to survey or to experiment with an entire group. It may just be way too large, and so there's no way to gather all of that data and that information. So what we do is we would create a sample that's a more manageable size of things that would represent the entire population, but that we could work with and gather data, and then we could infer our results to the greater population. So now, whenever I say finding a sample, it might be getting an alphabetical list of the students' names that are in the first grade and just going through and picking off every 10th student and surveying those parents. That would be a good representation of the entire population, but you would be having to survey a lot fewer people. It would be more manageable in collecting your data. So a population is the total group that you're working with, and a sample is a subset of that group, a smaller portion of the original group. Now I said that there were, sampling variabilities. There's, how you create your sample can make a huge difference. Um, our data could be compromised if we don't use what we call a simple random sample. In a simple random sample, each member of the group has the same chance of being selected for the sample. For instance, whenever we just talked about our school start time scenario, I decided to choose every 10th name on the alphabetical list. That is a simple random sample because each person has the exact same chance as the other person of getting selected. I just went and chose a random number to select of those students. If if on the other hand we were to decide to survey everybody in Mrs. Brown's class, well, that may not be a true representation of the population because let's say that the parents in Mrs. Brown's class are really involved parents and would be, absolutely willing to take our survey, whereas some other parents may not. Or what if they were altering school start time and Mrs. Brown's class was full of parents that had to be at work at a certain time and it would really affect them? So they would have a completely different idea um, than some other parents, maybe in Mrs. White's class, that maybe her entire class has parents where the one of the parents doesn't work, and so they could take the kids to school no matter what time school started. Do you see the difference in that? That we could bias or we could taint our data by just the way that we choose our sample. So you always want it to be random, just a randomly chosen group of people that would represent your entire population. Okay, there are steps in designing a survey or an experiment. Sometimes we call it surveys because we generally are talking about people or and how people feel about things. Your steps are, first of all, formulating questions. And this is an extremely important step because we want to make sure that we choose our questions carefully so that we don't bias the data. And we're going to see some examples here in just a little bit of a biased question versus a fair question. But in a biased question, you're unfairly influencing what someone would say just by word choices. So you want to be very, very careful that your questions are not tainted in any way, shape, or form. Then your next step is collecting your data. So once you have your questions that you're going to ask, then you're going to go ahead and do your survey or perform your experiment and collect your data. Then you would analyze the data, and this step entails figuring out, what you're going to do to report this. Are you going to use different kinds of graphs? What kind of graph would represent the data the best? How would you get your point across as to what you were doing? And then finally, interpreting the results. This is where you actually tell what your data represented, and apply it to the greater population and say, well, based on our findings, we, feel that the school start times would not affect students or whatever. Okay, so let's look at a couple of examples really quickly and see what we're talking about here. This first one says, decide whether each of the following questions is biased or fair and why. So the first question says, what is your favorite subject in school? Well, that is a fair question. And why is it a fair question? Well, there's there's nothing in there that would tell a person basically how you wanted them to answer. It doesn't influence anyone in an unfair way, so that would be considered a fair question. Part B says, do you enjoy the refreshing taste of ice cold soda on a hot day? This is a biased question, and can you figure out why it's biased? It's all in the word choice. Do you enjoy the refreshing taste of an ice cold soda? You have now given that person some kind of a visual almost of that refreshing taste. It is no longer just, do you enjoy ice colds? Do you enjoy soda? Period. That would be a more fair question. Do you enjoy soda? But you're tainting this question just by putting in those words that have connotations that make us feel, all warm and fuzzy inside. And we think, oh, yes, I would love to have a refreshing ice cold beverage on a hot day. Well, that's tainting or slanting our opinion there. Part C says, how much sleep do you get on an average weeknight? Oh, on average on a weeknight. Well, this would be a fair question because we're not using words that give us those warm and fuzzies or ickies on the opposite end. We're just simply asking a solid question. How much sleep on average do you get on a weeknight? So you want to be very careful about your word choices. Okay, let's look at another example here, if I can get the page to turn. Here we go. Okay, let's talk now about populations and samples. Determine the population in each of the following surveys and whether the sample is representative of that population. So part A says you ask 50 soccer fans sitting in seat numbers randomly chosen by a computer to rate the new stadium lights. Well, what would our population be here? We're going to be surveying 50 soccer fans. So our population then would have to be all soccer fans in that stadium. We're just choosing 50 of them as our sample. That's a smaller subset of the greater group. Now, is this representative of that population? Well, it would be, and because we are randomly choosing 50 people out of that group. So this is a random sampling of those students. So yes, that would be a fair representation. Part B says to find the average distance students have to travel to get to school. You survey the first 75 students coming through the main gate in the morning. Okay, so we're going to survey 75 of those students, and we're trying to figure out the average distance students have to travel to get to school. So our population, or our greater group, would be all the students in that school. All students in the school. That particular school, I should probably say. Now, is this representative? Is the first 75 students coming through the main gate, is that truly representative of all the students in the school? Well, not necessarily, because at this point you're only getting the first 75. What about people who come in a little bit later, or maybe are tardy, and how far they have to travel to get to school is just as important as the students who came in early. So you want to be very careful about not tainting your data. Then that way you're only getting a very small picture of your entire population. You're not getting the bigger picture. So that would not be a fair representation. Okay, part C says to find the average number of bicycles owned by a typical household in your town, you poll every student at your school. So what would be our population here? Our population is our the typical household in our town. So all households in our town. All households in town. Now, we polled students at our school to try and figure out the average number of bicycles owned in a typical household. Is that representative of that population? And in this case, the answer would be no. Because what about older people that don't have children in the school? Or what about young couples that don't have children in the school yet? Um, what about couples that don't have children, period? What about single people that, may or may not have children in the school? They could own bicycles just as well. So you're not getting a fair representation of your bigger picture by only polling the students. Okay, lastly, here in this question, it says you randomly select 5 students from each grade and measure their heights to get a better idea of the average height of students at your school. So, again, let's look at the population here. The population is going to be all of the students at our school. That's what we're wanting to find out about. All students at our school. Now, is randomly selecting 5 students from each grade and measuring their heights going to be a fair representation of that population? And in this case, yes, it would be, because you're randomly selecting 5 students from each grade. So that's a simple random sample of your greater population. So that would be, I hope that you're getting a better idea of the difference between population and sample and what represents a good sample also. Finally, here we have a university professor used a rating scale to evaluate her classes. Excellent class, number 1. Number 2, good class. Number 3, above average class. Discuss the rating scale and its usefulness in evaluating a class. Well, is that helpful in evaluating a class? Because it sounds to me like she's only talking about excellent, good, and above average. What about below average? We're not using a, a fair representation of the entire scale of what classes could be. There's nothing negative here. No way of saying, well, this was a really awful class, or something like that. We're just expecting that it's going to be above average at the very least. What about just an average class? We're not taking that into consideration. So our scale here is not a good representation of all the possibilities of outcomes. So we have to be very careful about doing that. This would not be a good way to use the rating system. We need more ratings. I hope that this has helped you to be able to understand a little bit more about how to design experiments and collect data. I hope that you have a better understanding of population and samples and fair and biased questions. And now you can go ahead and do your homework for this section.